Hello, everybody. Sorry I couldn't be there in class today, but what I'm hoping is that I can walk you through these notes, um, and then you'll have time in class to work on your homework for the next section. Now, what we're leading off with here, so I'll see if I can get all these on at the same time. I'm going to lead off with all of the answers to the homework for last night's assignment. Um, I'm going to scroll down here and let you see. Try and get everything on the page. You can pause this, obviously, uh, and compare your answers with the answers um, that you gave. See if you have any questions. Take note of them. We can go from tomorrow. Uh, I, I don't think that there should be any big issues here. But if there are, I want to spend time in class going over them, solving some problems, practicing together. Okay. In the meantime, once you get this done, you unpause the video. We'll move on and let's work on the next section, which is defining what an exponent of zero really means, and working with negative exponents. So let's just jump right in. Um, any power to the zero makes that value 1. It doesn't matter what it is, but whenever something is raised to the 0 power, the ultimate value is 1. So 9 to the 0 power is 1. 10 to the 0 power is 1. X to the 0 power is 1. 247.3 to the 0 is 1. So that's always, always, always going to be 1. A to the negative n is the reciprocal of a to the n, and a to n, the n is the reciprocal of a to the negative n. So I think what I'd like to do, instead of going over all these examples and all the rules, is I'd like to add in an example just to show you. Okay, so let's start with 2 to the third power, 2 to the second power, 2 to the first power. We know what these values are. 2 to the third is 2 times 2 times 2, which is 1, 4, 8. There you go. 2 to the second power is 2 times 2, which is 4. 2 to the first power is just 2, and that equals 2. What you can see here is that as we go down, and I'm going to keep changing colors here, as we go down, what's happening is we keep dividing by 2, right? And if I were to add another layer to this, if I went up one more just to make it a little more robust, 2 times 2 times 2 times 2, and that makes 16. So the factor is 2. How it's changing is by a factor of 2. Okay, so divide by 2. Well, can we keep going with that? What would happen if we went down another level? So 2 to the 0 power, or then 2 to the negative first power, or 2 to the negative second power. What will happen is it will continue to drop by dividing by 2. So if I divide by 2 again, what's that supposed to make? What is 2, this value of 2, divided by 2 again? What will it make? Well, it should make 1. What happens if I go down again and divide by 2 again? What will that make? 1 over 2. What happens if I divide by 2 again? What will that make? Well, that's actually going to make, if I divide by 2 again, it actually makes 1 over 4. Huh. Which is really interesting how that ends up playing out, because how else could I write 2 down here at the bottom? That's 1 over 2 to the first. How else could I write 4 down here at the bottom? That's 1 over 2 to the second. You see what's happening? As I write my negative exponent, it actually turns into the reciprocal, the fraction version. So the what used to be a base to the power of 2 now becomes the denominator with a 1 as its numerator. Now, you might want to refer back to this little table here to help make sense of what it means to raise something to the power of 0, but also what negative exponents are supposed to look like. So you can look back at these rules and refer back to them. 4 to the negative third power, if I want to write that simply, it's 1 over 4 to the third power. That's the only thing that changes. Negative 3 to the negative eighth power, this is negative 3 to the eighth power with a 1 on top. Now, could I also cancel out this negative? Yes, I can. So this is 1 over 3 to the eighth. Finally, negative 5 over 12, all of that raised to the 0 power. Well, what is that? 1 over 1 or just 1? Simple, easy peasy. Next slide. Not that one. All right. Lots of rules. Go back to these, refer back to these to help you solve problems. Let's look at negative 2 over 7 raised to the negative second power. Well, there's different ways you can do this, but first thing I might do is just say this is negative 2 raised to the negative second power, and then 7 raised to the negative second power. Because I have a negative 2 at the bottom, my denominator, this now moves up to the top. So all of this will move up to become 7 squared. And then this one, negative 2 raised to the power of negative 2, actually moves down to the bottom, switches places. And so this is 2 squared. I know it's getting a little messy here, but in the end, it becomes, this actually evaluates to 49 over 4. Ta-da! Here, 3 to the negative third power over 3 to the negative second power. Well, actually, I can just subtract these, right? 3 to the negative third minus 2 actually makes 3 to the negative fifth power. Or, coming back down, 1 over 3 to the fifth power. Ta-da! Last one, 4 times 2 to the negative fourth over 2 to the negative third. Well, let's look at this. This particular part becomes 2 to the negative fourth minus a negative 3. That's weird. 2 to the negative 4 minus a negative 3 is actually plus 3. So this is 2 to the negative first power, which is actually 1 over 2. So now I bring that back down, and this is 4 times 1 over 2, 4 over 2, or just 2. Ta-da! I know that was a little crazy. You might need to go back and watch that one again. And you may need to refer back to your examples in your books. But follow your rules, and it doesn't matter if it's negative or not. In the end, you'll make sense of it by placing the power at the top or the bottom of your fraction. Okay, let's keep going. Next slide. 0 to the negative eighth power. Everybody knows that's 0. 5m to the negative second power, n to the negative fourth. Well, I'm just going to rewrite this as 5 and 1 over m squared times 1 over m to the fourth. Once I work all this way through, it says 5 over m squared fourth. Simple. Down to the next one, I'm going to distribute this negative 2 to every power. So this is 4 to the negative second, x to the sixth, because negative 2 times the negative 3 is positive 6, and then y to the negative 10th. Once that's done, then I move down and I rewrite all these. This is 1 over 4 squared. So I'm gonna change this a little bit. 1 over 4 squared. I need to use my eraser real fast. Get rid of this. The next one is going to be, do a little adjustment here. x to the 6th times x to the 6th. And the next one is 1 over y to the 10th. Well, after I multiply all this across, I get an x to the 6th at top, and 4 squared, well, that's 16 y to the 10th. Hopefully this isn't too bad. And then I go through all of these, and I distribute this 0 everywhere. Guess what? What's this all equal to? It's equal to 1. All right. We keep going. Our next example. Oh my goodness, these are more complicated, but kind of fun. Hopefully you see it that way. I'm gonna, well, I don't have to do anything here, but I am gonna distribute this 2 down at the bottom so I can see this a little bit more clearly. Everything gets raised to the second power. So 4 to the second power, x to the negative 4th power, y to the negative 12th power. And then at the top, I still have 12 x to the 8th, y to the negative 7th. Okay. For problems like these, I start to divide all the different factors up. So now I've got like 3 different fractions that I'm dealing with. I've got 12 over 16, basically. And that's times, I'm going to change colors, x to the 8th over x to the negative 4th. And then that's times, I guess I didn't change colors there. And then y to the negative 7th over y to the negative 12th. No? Each one of these is going to play out differently. 12 over 16 is just like 3 over 4. This right here is x to the 8th minus a negative 4. That's how I evaluate that one. And then the last one is y to the negative 7th minus a negative 12. Well, eventually this is all going to work out. I get 3/4. Change colors. 3/4. 8 minus a negative 4 is actually 8 plus 4, and that's x to the 12th. And then negative 7 plus 12 is actually going to be y to the positive 5th power. It's interesting how it all ends up working out. Another way of writing this would be 3x to the 12th, y to the 5th over 4. Either one of those would be just fine. Finally, our last one for this section, I'm going to let you try that one on your own real quick, see how you do, and then check back in. I'll give you the answer here in a few seconds. Okay, there you have it, guys. Once you simplify this down, 12 over 4 makes 3. 8 minus a negative 2 is actually 8 plus 2. That makes x to the 10th. And then y to the negative 7 minus a negative 12. Actually, it's adding 12, and so you get a positive 5. There you go. When you move on to the last slide, you'll see homework's on page 506. Yay, we passed the 500-page marker. You're going to do 12 through 44, the evens. Please have this ready to go for class tomorrow, and we'll go over all answers together. Have a great day, guys, and make good use of your time, okay? All right, bye.